Welcome to Lotus Student Mentor channel. In this session, we are going to learn the max product relation or composition of two fuzzy relations through solving the problem. Here, find max product composition of two fuzzy relations. One is R equal to 0.6, 0.3, 0.2 and 0.9 in matrix form, and S in matrix form is 0.9, 0.5, 0.3, 0.8, 0.4 and 0.7. These are all membership values. What is the max product says? What is the product of max product? If you want to calculate anything, suppose as I mentioned as a maximum relation, that is T equal to R times S. Now assume that it is x1, x2, y1, y2, and it is y1, y2, z1, z2 and z3. The new relation will come in matrix form. Here it is x1, x2, okay, and here z1, z2 and z3. You have to find out these values. So if you know the concept of matrix multiplication, the size of this new max product fuzzy relation in matrix form is, here it is R is in 2 by 2 dimension and here it is 2 by 3. The combined R and S is 2 by 3. Matrix form comes. Alright. We have to find out x1 z1, x1 z2, x1 z3, x2 z1, x2 z2 and x2 z3. So mathematical relation for this max product relation is that mu of t of x1 z1. What is the mu of t of x1 z1 is maximum value of, okay, that is membership ratio, membership value of, what is the membership values here? The membership values of x1 y1 product and y1 from this, that is mu r, from this mu s set, that is y1 z1, comma, these two products, maximum value product of x1 y1, what is the x1 y1 here? 0.6. What is y1 z1? 0.9. Both product, comma. Next, mu r of x1 y2. What is the x1 y2 times mu s of, what is the mu s of y2 z1. It is very simple if you know the concept of matrix multiplication term. 0.6 into 0.9. Okay, next 0.3 into 0.8. What is that? 0.6 maximum of 0.6 times 0.9, okay, comma, 0.3 times 0.8. What is the 0.6 into 0.9? What is it? Comes maximum. What is the 0.6 into 0.9? The 0.6 into 0.9 is that equal to 0.54. 0.3 into 0.8, that is 0.24. What is the maximum? Maximum of these two values, that is 0.54. That is the mu t of x1 z1 components. Okay, similarly, if we apply the concept of mu t of x1 z2, what is the x1 z2? Maximum of, I am applying the concept of here, this position we want this value, that means 0.6 into this horizontal component into 0.5, 0.6 into 0.6 into 0.5, comma, next 0.3 into 0.4, 0.3 into 0.4. Okay, what is the maximum in this value? Maximum of 0.6 into 0.5, that is 0.3, 0.3 into 0.4, that is 0.12. What is the maximum value? 0.3. The next step, what is the next step? x1 z3 is required. What is x1 z3 in this? Mu t of, what is the mu t of? Mu t of x1 z3. Mu t of x1 z3, how to obtain? Again 0.6 into 0.3, the maximum values of product 0.6 into 0.3, comma 0.3 into 0.7. What is 0.6 into 0.3? That is 0.18. 0.3 into 0.7, 0.21. What is the maximum? That is 0.21. Okay, next we got it x1 z1, x1 z2 and x1 z3. What is required? Next x2 z1 is required. How to get x2 z1? That is mu t of x2 z1. What is x2 z1? Now you consider this 0.2 into 0.9, the maximum of 0.2 into 0.9, comma 0.9 into 0.8. What is the maximum of 0.2 into 0.9? That is 0.18. 0.9 into 0.8, 0.72. What is the maximum? That is 0.72. Okay, next step. What is how to calculate? Similarly, if you apply the same methodology, that is mu t of x2 z2. What is x2 z2? Maximum of, what is x2 z2? 0.2 into 0.5, that is 0.1. Next 0.9 into 0.4, that is 0.36. What is the maximum value? That is the 0.36. Next mu t of x2 z3. What is x2 z3? Maximum of, what is the maximum of? 0.2 into 0.3. What is the 0.2 into 0.3? 0.6. 0.06. Next 0.9 into 0.7, that is 0.9 into 0.7, 0.63. What is the maximum here? 0.63. Now substitute here x1 z1, x1 z2 and x1 z3. What is x1 z1? As shown here, x1 z1 values. What is x1 z1? x1 z1 is 0.54. The final max product mu t of max product is relation equal to x1 z1 is 0.54, x1 z2 0.3, next x1 z3 0.21 and x2 z1 0.72. Okay, and what is x2 z2 0.36 and finally it is 0.63. This is the max product relation of max product composition of the two fuzzy relations. In the next video I am going to share directly how shortcut of max product composition of with the two fuzzy relations and compare with the same answer. Okay, thank you for watching.